on factors and multiples. And here we consider that, for example, if I give you 40 divided by 8, we obtain 5. Meaning that 8 and 5 are factors of 40, right? And why are we saying they are factors? Because if a number can be divided by another number without a remainder, the second number is a factor of the first. And also even the product is also a factor of the first number. I hope you just got that. Here the product is 8. Here the product is 5. But in the second number is 8. These two are both factors, while a 40 is the first number. This is simple stuff. And for example, we can have examples like factors of 40. Let's say factors. Let me just list them down. Factors of 40. We've got 1, it's a factor. 2, it's a factor. 4, 5, 8, 10, 20, and 40. 40 as itself, it's also a factor. Okay, so if you are asked to list the factors of 40, you'd just do this. This is just fine. It's not bad. Just do this. So factors of 40, you just do this. Yeah, it's okay. Moving on to prime numbers. Prime number has only two factors, itself and 1. Prime. Yeah, on prime numbers. So on prime numbers, we are saying a number has got two factors, itself and 1. So you're saying itself and 1. That's what we are saying on a prime number. The likes of prime numbers are examples of prime numbers. We have 2. Yeah. So for you to understand a prime number, you have to think, if I say 2 is a prime number, which other number can be multiplied, can be divided into 2 and giving me another number which is not 1 or itself, right? Like which is not 1 or the number itself. So 2, we can say 2 into 2 we get 1. If you say 1 into 2, you just get 2. So you just have to get two things, the number itself or the 1. Though 1 is not a prime number. Okay, guys. So the other prime numbers we have is 3. Yes, 3. Come to think of it, 3. There is no other number that multiplies itself to 3 except for 1 and 3 itself. 5, 7, 11, 13. There are so many. And so they're just many, we cannot finish them. But important point is 1 is never a prime number. 1 is not a prime number. Okay. 1 is not a prime number. So that's it. Okay, guys, we are now moving on to prime factors. Prime factors. This is a prime factor. Prime factors of a number are factors of the number which are prime. The numbers of the factors of the number which are prime, but they are factors. It is possible to write every non-prime number as a product of its prime factor. It is possible to write every non-prime number as a product of its prime factors. For example, let's say 15. To obtain 15, we can say 3 times 5. These 3 and 5 are prime factors. Yes, they are factors, but they are also prime. That's the point we are saying. We are saying the numbers have to be factors first, and they have to be prime. Which other numbers can be? No, there's no other number, right? 15. We also have 24. We can write it. You can be asked to write in the write a number in the product of its prime factors, right? So you can say 3 times 5, like we did here. On 24, it will be like 2 times 2 times 3 times 2, right? Times 2 times 3. 2, 2, 2. These are prime numbers, and they also factors. And 3 is also a prime factor. So that's all about this part, guys. Nothing much. Okay, guys, we are now moving on to HCF, or highest common factor. Highest common factor, or HCF, right? HCF. HCF, or yeah. So the question that I've got says, reads out, find the HCF of 18, 24, and 42. Find the HCF of 18, 24, and 42. Okay, find the HCF of 18, 24, and 42. Now this is just simple. We just find the factors of 18, the factors of 24, the factors of 42, right? So we're going to say F18, F for factors. Factors of 18, we have got 1, 2, 3, 6, 9, 18. Factors of 24, we have got 1, 2, 3, 4, 6, 8, 12, 24. So, factors of 42, we have got 1, 2, 3, 6, 7, 14, 21, 42. Sorry for that. Okay, everything else is visible. So we are saying by inspection, you have to check your things, check your work. So now by inspection, we find the common factor which appears in all 3 numbers, F18, F24, F42. The common factor which appears in all 3 numbers and being the highest. Okay? In this case, we have got 18, but 18 doesn't appear here or here, so it cannot be a common factor. We also have 9. 9 does not appear here or here, so it cannot be a common factor. We have 6. 6 appears here, here, and here, meaning that 6 is our common factor, our highest common factor. HCF is equals to 6. Okay, so this is our answer. If you've got any questions, do comment, do ask on the comment section, do ask whatever. I am free to explain anything you want. Okay, guys. Okay, moving on to multiples. Multiples. We're going to talk about common multiples. We're going to talk about common multiples, and for example, if you say multiples of 6, these would include 6, 12, 18, 24, depending with the range you are given. Each number in the set 6, 12, 18, 24 has 6 as a factor. So we are having these as common multiples. For you to easily understand multiples, wow, it's kind of crooked, but that's how we get it. Kind of multiples of 6. You cannot say a multiple of 6 and tell me of 3. No, you can't say that. It's not it. Yeah. So if you are talking of multiples of 6, you have to say 6 first. We have 12 and moving on. Every number which we can yatinokwanisa kuti ipintwe na 6, right? Without leaving any remainder, that's the multiple we are talking about, right? So we cannot say 6 into 3. No. Yes, it can, but we now have a process. It's no longer what we want. It's no longer a multiple. So we are going to say, so I basically just have to understand that if we are talking about multiples, it has to be higher than the number that you are given. That's it. It got to be higher than the number you are given. And moving on to lowest common multiples. Lowest common multiples. On lowest common multiples, guys, this is really easy. Let me give you an example. 30, 60, 90 are all common multiples of 6, 10, and 15. 30 is the lowest number that 6, 10, and 15 will divide into. We say that 30 is the lowest common multiple of 6, 10, and 15, right? LCM is the short, kind of here. Okay, let me just explain for someone who is just seeing this now. Okay, what we are saying there is, when we were talking about highest common factor, we were looking for the highest number with which that number goes into the other numbers. For example, there we had F18, F24, F30. Was it that? 30 was 42. So we are looking for something which would go into both F18, F18, F12, F18, F24, F14, without leaving a remainder, but being the highest. But now when you are talking about the lowest common multiple, we are now looking at the lowest, like the lowest number that would go into, the lowest number that would, okay, never mind. So let us say you find the LCM of 8, 9, and 12. Let me just make sure you understand this. Find the LCM of 8, 9, and 12. So on multiples of